Hello, my name is Ljubomir Jančev and I'm the CEO and founder of MClimate. We started the company 10 years ago with a mission to decarbonize buildings. We create solutions that are meant for rapid retrofit and can help you unlock those 30 to 40% of savings that are really easy inside a building. We're known for our thermostats, for our solar power devices, or for our battery powered sensors. But today, I'm here to show you two new devices that we've developed and to tell you what are the similarities, what are the differences, and what applications can you use them with. Here I have the 16 amps switch and power meter, as well as the 16 amps dry switch. As you can see, both devices are super small. We intentionally made them as small as possible so that we can fit them behind wall switches and outlets. We intentionally made them 16 amps as well, because the electrical code in most of the countries in EU dictates that you should use 16 amps fuses. So this is able to handle as much power as the fuse in your panel box. And now we're proud to have the smallest but also the highest rated LoRaWAN relays on the market. Now let's get into some details. As you can see, both devices are the same size. It's 32 by 36 by 80 millimeters. The only difference is the color as well as the wiring diagram in front. They both have the same VDE and UL certified relay inside, and they can be powered from AC voltage or DC voltage, namely 100 to 240 AC or 24 to 30 volts DC. The terminals you can see here are from renowned EU manufacturer of terminals, and they can accept anywhere from 0.5 to 4 millimeters squared stranded or solid core wires. The main difference between the two devices are the wiring diagrams. The 16 ASPM features a switched live relay, which means that whatever you power the device with is going to appear at the output. Whereas the 16 amps dry switch, there the power supply and the output are completely separated. And you can see it by the wiring diagrams. For the 16 ASPM, we have the L and then we have the relay in the middle, and then you have another terminal L out. So with L and N, you power it up, and then when you close the relay, the signal appears at L out. Whereas with the 16 amps dry switch, it's another situation. Here we have N and L for power supply of the device itself, but the circuit that we're controlling is actually between terminals I and O. Furthermore, the 16 ASPM has an electricity meter inside. It's as accurate as any other MID certified meter that is used by utilities for billing purposes. But we couldn't certify it for MID because we had to put a display and we wanted to keep it as small as possible. And last but not least, about protections. Both devices have over temperature protection, meaning that there is a temperature sensor right next to the terminals, which monitors the internal temperature of the device. This can save you in case the electrical installer hasn't fitted the wire quite right in or hasn't screwed the terminal well enough, so you can see and be protected. But the 16 ASPM, also having an electricity meter, has over current protection, over power protection, and over voltage protection. And now about the use cases. The 16 amps switch and power meter, or the 16 ASPM, you can use it for anything that you want to control, but you also want to monitor. So for example, a water heater, electric water heater, an electric space heater, electric underfloor heating, anything you want to control, but you also want to get the consumption of. Or maybe you just want to monitor something. Maybe you don't want to control anything, but just want to use its electricity meter to measure. Whereas the 16 ADS, it has quite different applications that the 16 ASPM cannot do. For example, garage doors, barriers, gas boilers as well, and other things. But here you're lacking the electricity meter, but you get a dry switch. And here you get an electricity meter, and in some cases, depending on the wiring, you might have to use less external connections. You can also combine both devices with other MClimate products. For example, if you're controlling an electrical space heater, you can also use the wireless thermostat we have. So the users can adjust the target temperature from there. It can measure the temperature in the room, And then it can send commands to one of those two devices to turn on or off the electrical space heater. And it goes without saying that both devices can be used with our MClimate Enterprise, which is a software for management of buildings. And in the software, you can obviously see the current readings, but you can also see historical insights. You can create on-off schedules, you can view the history, there are lots of things you can do, but it's a great starting point to test those devices. And of course, both devices are with open protocol, meaning that they can be integrated into any system you wish, be it an IoT system or be it the BMS itself. We have all the documentation publicly available and we commit to continue doing so. Thank you for joining me today. If you have any questions, please feel free to reach out to us and see you in the next one.